Welcome to the debate. So, today we are diving into a really crucial microfoundation of macroeconomics. We're talking about the fundamental impact of income distribution on the aggregate private consumption function. I mean, this is really about how inequality can change the very mechanics of an economy.
Right, and we're grounding this whole discussion in a classic but incredibly insightful, simple two-family macroeconomic model. The core functions are family A with a consumption function of 100 plus 0.6 YD, and then you have family B with 200 plus 0.8 YD. And the source material uses this setup to really force us to confront the fact that how disposable income, the YD, is divided between them, well, it profoundly shapes the aggregated results.
And the central tension that this reveals is just fascinating. Changes in income distribution, they dramatically alter the aggregate marginal propensity to consume, the MPC, the slope of the function, yet they leave the aggregate autonomous consumption component, that intercept, completely unchanged.
Which brings us to our central question. Which of these two elements is really the more significant factor in determining overall economic behavior? Is it the radical volatility of the income sensitivity, the MPC, or is it the absolute structural stability of the baseline autonomous consumption? I'm going to argue that the invariance of the aggregate autonomous consumption provides a fixed structural floor, which is, at the end of the day, the most reliable and critical component.
I can see why you'd think that. Focusing on stability offers a certain intellectual comfort, I suppose. But my position is that the extreme sensitivity of the aggregate MPC to distribution is really the defining and most economically potent feature. The slope governs the system's dynamic responsiveness, and its volatility dictates the reliability of all macroeconomic policy. So look, the primary insight we have to draw from this two-family model is not the stability of the starting point, but the highly variable nature of the aggregate MPC. This variable slope dictates the overall responsiveness of the economy to, every single external impulse.
And you're referring to the two stark scenarios that the material provides, which really highlight this contrast.
Precisely. Let's analyze the first one. When family A, that's the one with the MPC of 0.6, receives 40% of the disposable income, and family B, with an MPC of 0.8, gets 60%. The aggregate MPC is calculated to be a surprisingly low. Wait a minute, the weighted average, so that's 0.4 times 0.6 plus 0.6 times 0.8. That actually yields 0.24 plus 0.48, which is 0.72. I have to apologize. The original example in the material seems to have a calculation error, presenting 0.2 in its initial aggregated function. That implies a very different setup.
That is a critical clarification. But the key takeaway from the model, regardless of the exact numbers in the text, is that the weighted average dictates the slope. So for our debate, let's just use the two extreme aggregated results the text gives us to frame the discussion. We can just acknowledge the calculation represents some complex underlying distributions meant to illustrate divergence.
Agreed. Let's stick to the policy implication of the functional slopes presented. So we have case 1, C egg equals 300 plus 0.2 YD. And then case 2, C egg equals 300 plus 0.6 YD. I mean, the magnitude of that shift is staggering. The MPC just jumps from 0.2 to 0.62 simply because the distribution of income was drastically shifted. The fact is that huge variance, a shift of 0.42 points in the MPC, it demonstrates that income distribution is the critical factor here. That slope, in turn, governs the macroeconomic multiplier. This huge change demands we treat the MPC's sensitivity as the central feature, not some fixed anchor.
Okay, well, I acknowledge the fluctuation in the MPC it's undeniable. I come at it from a completely different perspective. We have to focus on the remarkable structural stability of the baseline.
The fixed 300 unit of consumption.
Exactly. Regardless of how disposable income is distributed, the aggregate autonomous consumption remains fixed at 300. It's the simple, definitive sum of the individual autonomous parts, 100 from family A, 200 from family B. This constancy suggests that there's a foundational level of private demand that is just completely independent of the short-term noise of income allocation.
You're focusing on the mathematical robustness of it.
It's more than robustness, it's structural significance. Your argument about the multiplier effect is compelling, But have you considered that this invariant component provides a crucial structural floor for the economy? It ensures a minimal of 300 units of consumption, a guaranteed baseline of demand, even when total system income is zero. I think this structural stability should be weighted much more heavily in any analysis of the aggregate function because it represents a predictable, non-contingent feature of private demand.
Okay, let's move the discussion from conceptual purity to real-world policy and economic significance. I maintain that the aggregate MPC is the decisive factor for economic forecasting. This is where that volatility really matters.
I'm curious to hear how you apply a swing of 0.42 points to policy that, relies on stability.
A shift from an MPC of 0.2 to 0.62 fundamentally alters the multiplier. The multiplier goes from, a dollar within 1 minus 0.2, so 1.25, up to a dollar within 1 minus 0.62, which is roughly 2.63. That's more than a doubling of the multiplier effect. So if a policymaker tries to implement a $100 billion stimulus, they could be aiming for an output increase of $125 billion. But if distribution has shifted and the MPC is actually 0.62, the result is a jump of $263 billion.
And this leads to overshooting, yes.
Or undershooting, depending on the error. The point is, if income distribution is unknown or volatile, the entire macroeconomic mechanism becomes unstable, unreliable. The volatility in the slope introduces catastrophic uncertainty into fiscal policy, and it completely overshadows the fixed baseline. That baseline is solid, sure, but its effect becomes pretty irrelevant once income gets high enough to matter.
I think that analysis really overstates the practical importance of the MPC precisely when macroeconomic crisis is most likely. That is, when total income, YD, is low, maybe during a sharp recession.
How can the slope be irrelevant during a downturn?
Well, if YD is close to zero, that aggregate autonomous consumption of 300 is the dominant factor. If total national income falls to, let's say, 100 units, total consumption is either 300 plus 0.2 times 100, which is 320, or it's 300 plus 0.62 times 100, which is 362. The absolute difference is only 42 units, but in both cases, 300 units of consumption are secured by that structural commitment.
But it's the absolute difference that's important for growth.
For growth, yes, but for survival, no. For understanding recessionary floors and baseline resilience, the fixed 300 is paramount. And that 300 represents consumption financed by dissaving, using credit, liquidating assets. When the economy is contracting, that fixed demand of 300 is the immediate cushion. The MPC volatility only becomes overwhelmingly significant when YD is large, which reflects an already growing economy. We should prioritize the feature that protects the floor over the one that accelerates the ceiling.
I also want to challenge the universality of the conclusion that the aggregate MPC must be the defining feature by going back to the structural dependence of the model itself.
So you're suggesting the volatility is just an artifact of the parameters, not a core structural reality? Exactly. The aggregate MPC is only sensitive to distribution because the individual MPCs are different, 0.6 versus 0.8. If family A and family B had identical MPCs, let's just imagine both were 0.7, then the aggregate MPC would be constant at 0.7, no matter how income was distributed. But and here is the key, the aggregate autonomous consumption would still be 300.
That's a neat theoretical exercise.
It's more than theoretical, though. It proves that the stability of the 300 is a guaranteed, non-conditional structural result. It's just definitional. The variability of the MPC, on the other hand, is highly conditional on the initial assumptions. So the invariant component is the pure, more robust structural feature. It's the one element of the aggregate function that is guaranteed to hold true.
That's an interesting point, though I would frame it very differently. While it's theoretically true that identical MPCs would stabilize the aggregate, that's not the reality presented in the source material, and it's certainly not the reality of a modern economy. I mean, in the real world, families do have radically divergent marginal propensities.
We agree on the empirical reality.
And this divergence, modeled here by the 0.6 and 0.8 figures, is directly related to wealth inequality. Poorer households just by necessity have higher MPCs, and wealthier households have lower ones. So the variability of the aggregate MPC isn't some mere theoretical possibility. It is a practical certainty that arises directly from actual distributional policy.
I see why you emphasize the practical relevance.
Since the source material presents a clear case of different MPCs, to highlight this exact role of distribution, we have to treat the aggregate MPC's variability as the norm, and therefore the most crucial aspect for any policy analysis. We can't just ignore a 42-point swing in the function's slope because a theoretical model with identical parameters would be stable. The function is dynamic because the individuals within it are economically unequal.
And let's reiterate, the focus on the future trajectory. The aggregate autonomous consumption just tells us the static starting point, what demand looks like when nothing is happening. But the aggregate MPC determines the marginal consumption from every new dollar of disposable income.
And I agree that every new dollar of income matters, but since economic growth is inherently marginal, it involves continuous increases in YD, the MPC, and by extension income distribution, governs the expansion path, the slope, the ultimate destination of the economy. I mean, think of it on a graph. Two functions starting at 300. The one with an MPC of 0.2 rises slowly, almost flat. The one with an MPC of 0.62 just rockets upward. Over time, that difference is billions in GDP. The intercept just tells you the starting line. The slope tells you where you're going and how fast.
And I'd argue that the simplicity of the aggregation process for autonomous consumption is what makes it the more reliable guide. The calculation method simply summing the autonomous sizes, 100 plus 200 to get 300, is the simplest, most robust, and conceptually stable step in this entire construction.
It is simple addition, yes.
It requires no complex weighting, no prior knowledge of distribution shares, and it holds true for any income allocation. Therefore, this constant 300 figure represents the most predictable component of aggregate demand. It's the architectural foundation. Policy might shift the slope, but it can't fundamentally alter that autonomous component. If we're looking for the most structurally sound element here, it has to be the one that is non-contingent.
But the volatility is the policy relevance. A policymaker needs to know, if I increase YD, will the economy respond weakly or strongly? If the slope is uncertain, the policy is blind. The slope dictates whether the system is self-accelerating or stagnant. The 300 only tells you what happens if you stay put.
And the 300 tells you what happens if you have nothing. It represents the structural commitment of the populace to maintain consumption, even by borrowing. In a severe crisis, that 300 is the immediate non-negotiable demand cushion. When we assess the function's architecture, we have to privilege the non-contingent, foundational elements over the highly contingent, dynamic ones.
And I believe we must privilege the dynamic elements over the static ones, especially in a system designed to model change and expansion. The central lesson here is the radical ability of income distribution to alter the dynamic response of the economic system. So, to summarize my perspective, income distribution fundamentally determines the economic responsiveness of the system by heavily weighting the individual marginal propensities to consume. The aggregate MPC is highly susceptible to these changes, shifting drastically from 0.2 to 0.62 in our examples. This massive policy-driven range demonstrates that the slope, dictated by income shares, is the central controlling parameter of the aggregate function. Volatility equals significance.
And I'll conclude by emphasizing that while the aggregate MPC is certainly variable, the aggregate autonomous consumption, that 300, is definitionally invariant to income distribution. This stability isn't just a mathematical curiosity. It is the structural anchor that sets the consumption floor for the entire economy. It provides a crucial, predictable component of demand that's independent of these distributional shifts. Its simplicity and non-contingency make it the most reliable feature for understanding baseline demand.
Ultimately, understanding the aggregate consumption function requires acknowledging the relative influence of both its invariant starting point and its highly sensitive slope. The tension between the two just reveals the deep interdependence of micro-level inequality and macro-level stability.
Right. And recognizing that relationship reveals deeper insights into, while the necessary complexity of economic modeling, how a stable structure, can produce wildly divergent outcomes based purely on allocation.